For this we have KNO3 is mixed with water. Is the solution basic or acidic? And then they ask, is ClO a weak acid or base when mixed with water? So for this, these are a little bit tricky, I won't deny, because for this we have to really know what they split into. So let's start with, so A is KNO3 and B is ClO minus. Okay? So we have, if we just draw the form, we have K plus, well, KNO3 mixed with water. We're going to do a substitution. That's what we're going to aim for. So I'm actually going to write this as HOH. Because that turns into KOH plus HNO3. That is the first one. Second one, we have ClO minus plus HOH. We have typically HClO plus OH minus. Okay? So with that being said, this is where it gets tricky. This part, frankly, I don't think it's as easy to memorize, but the best thing I would memorize would be a list of strong acids and bases. And if you don't see them, then, if you don't see that in your products, then you know you're working with weak acids or bases. So with that being said, we have KOH. Anything with hydroxide typically is already a strong strong base. So we can kind of ignore this, okay? Because strong base means that even though I've written KOH there, potassium has literally no business wanting to be with the hydroxide again. That's what it means to be a strong base. It dissociates completely, aka even if they're flowing the same water, potassiums and hydroxides, they will not rebond together. They'll rather stay separate. And now HNO3. Nitric acid, unfortunately, barely passes the bar for a strong acid. So this as well, no interaction. The hydrogens will like to be by themselves, and the nitrates will just float by themselves as well. So I crossed them out because that's all we have. All we have is strong acid and bases. And when you have that, funny enough, the solution would be neutral. So they didn't even give that option, but that is an option you can go for. The solution will remain neutral because these salts, the KNO3, well, not just these salts, I guess this one salt, KNO3, is made from a quote-unquote strong acid and strong base, as I've shown here. So because of that, this salt will not want to interact anyway with the water to make it acidic or basic, because they're never even interacting in the first place. So that is why this would actually end up being neutral. And so to clarify, if you see that the quote-unquote products, as I drew this formula, is just going to be a strong acid and a strong base, if you don't see anything weak there, it means that it's not going to happen, if that makes sense. Because KOH would never be a product that you'd see, because the potassium and the hydroxide don't want to interact. Same thing with the HNO3. And because that is happening, you know that you have a neutral salt. So with the next question, is ClO a weak acid or base? So referring back to our list, we have ClO, or at least HClO is not, at least from what I can see, that would be like hypochlorous acid. There it is. This is a weak acid. So there is interaction there. If you put ClO, ClO minus, it would actually go with the water and try to take some of the hydrogens from it, forming this base. So that makes this the base. This would be the acid, and this would be the conjugate acid, and this would be conjugate base. So specifically referring to the ClO minus, when they ask if it's a weak acid or a base, as you can see here, the answer, this would be a weak base. Okay? So now with that being said, these are the answers for it. I'm going to refer to my colleagues so they can actually elaborate more on the whole KNO3 situation, just to be able to pick out some keywords in case my explanation did not make sense. So, KOH, as they did, they actually did the reverse formula to make it shown a little bit easier. KOH is a strong base and HNO3 is a strong acid. So salts of strong bases and strong acids, the pH will remain neutral at 7. Think of it as a neutralization reaction where they just cancel each other out. Okay? Based on this rules, KNO3 is not an acid or base because the solution of KNO3 dissolved in water would be neutral because it's from a salt of a strong base and strong acid. Okay? So now with that being said, NaClO is a salt which dissolves in water to give us the ClO minus that we're looking for. Okay? So if ClO minus works with acid, it will be HClO4 minus or plus OH, which is what we got here. Okay? But it says here that ClO is a strong acid when mixed in water, which may be a fair mistake, but it is a mistake nonetheless, because as we see, we have different ones. We have perchloric acid, which is a strong acid. We have hydrochloric acid, which is a strong acid. And we have chloric acid, which is also a strong acid. But hypochlorous acid, which is all the way down, as I saw before, but I've now lost it here. And this is a weak acid, because that's what we have here as ClO minus. And you know it's a weak acid because it has a Ka value, dissociation constant, that's less than 1. Okay? So with that being said, this unfortunately is wrong. And not only is it wrong in the acids and bases, it actually is wrong in regards to it is a weak base, not even a strong acid. I think they just got it switched around somehow, because they say that this is a weak acid. Hypochlorite is a conjugate base of the weak acid HClO. So when you're a conjugate base of a weak acid, you're also most likely a weak base, because if you don't dissociate completely to one side, if I added the opposite, it also wouldn't dissociate completely to the other, or resociate completely to the other side. So typically a weak acid's conjugate is also going to be a weak base. Okay? It's just going to be relative, I guess. This is where it gets a little bit tricky. A weak acid that's close to being a strong acid will have a conjugate of a weak base that's extremely weak. So if I were to like draw a chart, the stronger the acid, the, I guess, weaker the base, if that makes sense. It's a little bit hard to draw because, yeah, it's very hard to draw. But yes, I would just stick with weak acid will lead to a weak base. So this is incorrect. ClO minus is a weak base, which you can see here on the acids and bases sheet. Okay, if we did, where is it? Lost it again. Hypochlorous, there we go. We can actually just use this. The pKa is 7.46/7.53. So the pKb will be 14 minus that. Let's use the one that's even more basic. 14 minus 7.53. That's like an extremely weak acid. Almost, you could argue that it's basic almost. But nonetheless, we have 6.47. So if I did now the 10 to the power of negative that answer, our KB is sitting around 3.39 times 10 to the negative 1, 2, 3, 4, 5, 6, 7 times 10 to the negative 7. Okay, because that KB value is still less than 1, it's still going to be considered a weak base. So with that being said, that was incorrect. And we can now move on to question number 26.